reproducibility in agent research. So has anyone used any AI agents before in your work?
AI, Cloud Code.
Yeah, Cloud Code. Yeah. So you use the Cloud Code harness.
Visual Studio.
Yeah. So anyone else uses Cloud Code, or say anyone familiar with OpenClaw? That was a huge thing. That was a huge thing. Yeah. So your personal AI assistant that you can talk to via WhatsApp. Okay. So so today's talk will be about agent research, but specifically reproducibility, right? Because you can do this and that in agent research, but a huge challenge is actually reproducibility, because as you know, LLMs are stochastic. If you put in the same prompt, the same settings, the same hyperparameters, everything, the inference is, what you get at inference time may not always be the same. Even if you set the same seed, zero temperature, it is still likely or somewhat likely to give you something that is not bitwise identical to the previous generations. So AI agents are powered by LLMs. A lot of agents today that we use, which are subject of active research, are also based on LLMs. So it's important for us to be able to look at the results of a paper and say, okay, we can audit this, or okay, we can reproduce this in our own lab. Otherwise, it's the numbers. If your numbers are different from mine for the same task, then it becomes absolutely meaningless when you talk about benchmarks, when you talk about ranking, and when you talk about the improvements in terms of harness, etc. So something has happened to our slides.
Zoom session.
Zoom.
Jangan. Zoom online.
Who prefer France? France and Norway.
Europe Cup. After the COVID,
So when we talk about AI systems, I believe in a previous talk we talked about how classical computers, not AI systems, they would turn an input, process it using certain code, and you turn it into some output, right? But AI systems would be something that you don't necessarily have to code for, but you can put in the data, it kind of learns patterns from that data, and comes out of the output. So most AI systems turn an input into output. And for instance, you have an email filter, which classifies emails as scam or unscam, images, photograph, label, or caption. You might have a basic chatbot, which you can give it a question and it will provide a written response. So in this case, you give it a query, is trained and it produces an output. The language model is a model that is the part of the agent that produces language. It can draft or rewrite text. It can summarize the type of material. It can reason using the text. Right? But what it can't do is, for instance, a base model or ChatGPT cannot know life prices of a certain commodity stock, take ticket, or other sort of. It cannot open your calendar or code base or database to check what is available. It cannot send an email. It can't do any of this, right? The core part of the large language model. It is just a producer of language. It is given a prompt, certain context, and it produces some sort of output. Right. So for instance, the chatbot can advise you, right? You can say that I want to find a 30-minute time slot for Anna and me next week to meet. So the LLM itself doesn't know when I'm free, when Anna is free or Ben is free. They don't know any of that. What they can do is connect to the calendar, and it can complete what we call workflow, right? To find a mutually available time. And once it compiles the free time, it finds a slot, it sends the invitation. And so you have but if it's just a conversation interface alone, it does nothing. It can't talk to the calendars, it can't propose a time, and it certainly can't send a calendar invitation for everyone to accept or reject, and for it to eventually land on calendars. So this without the calendar integration, this is just a chatbot, a large language model. With this integration, this is a very simple agent, and it is a calendar agent that can help you find a free time to meet with someone else and send invitations. So the calendar that we spoke of just now is a tool. So large language models today, or AI agents of today, are capable of tool use, right? And specifically how they make use of tools is that when they, for instance, want to run an internet search, their output tokens will include a structured output that enumerates exactly what they want to search. And that would be processed by what we call a harness, which is what orchestrates the activities of this AI agent. All right. So, for instance, when you ask the AI agent, hey, find me some news about the Iran war. Right. So the AI agent will use its language reasoning to think of some keywords that might be useful in helping it locate some of the important news about the Iran war, and then it would, output these search queries in a nice form that the harness now knows that okay, we are going to use this to search and feed it back to the chatbot and so on. So some of the tools that chatbots use nowadays is search. It can calculate, right? So 2 years ago, people used to say that chatbots are notoriously bad at math. So now, instead of trying to use its language functionality to reason in math, it would call the tool called calculator. It would basically send a query to a calculator in a certain format, the calculator performs this in a deterministic way, right? And feeds it back to the AI, and it says, okay, this is another calendar we talked about, email, database code, right? You can say, one of the important benchmarks of large language model nowadays is how well it can use a terminal. So, for instance, can it search through your system files and find certain keywords inside? Can it run a Python server to host a small test object that you're trying to code, so on and so on. So, and database, right? It might, LLMs are also capable of writing SQL queries and so on to the database. Every tool has a request and a result, right? So you might have a request to ask the tool to help you find a 30-minute time slot, and the result might be that Wednesday 3:30 p.m. is free for all people. You can also return stuff like no result, permission denied, and so on and so on. Of course, in terms of AI safety, you want to make sure that the agent doesn't actually overstep its boundaries, right? When you talk about another than me, you don't want the tool to suddenly access the CEO's email and add a bunch of nonsense anonymous calendar. That would be very nice. And of course, you can also set certain boundaries that I don't want you to make any appointments yet. I don't want you to send out applications yet. I just want to know what that is and so on. Okay. And yes, some tasks require something called context, which is what has been in the conversation up to this point. And so it might be stuff like order numbers, it might be stuff like previously retrieved websites, previously retrieved information. And so you might have a workflow, for instance, which involves a bank loan application. And this, for instance, the customer submits a loan for the bank. It might get passed on to a sub-agent who is looking at, say, verifying the customer's income. There might be another agent that is verifying the customer's credit information, make sure that they're not in default on previous loans. And so all that comes back, and it becomes context for the last agent to process and decide, okay, do we really want to give this customer a loan, right? In fact, 2 or 3 years ago, one of the hot and upcoming job roles was prompt engineer, right? So you would give AI very grand-looking, very detailed prompts for them to think about, for them to follow instructions and form them according to your wishes. Nowadays, the more hot, of course, prompt engineering will not get you a job anymore in 2026. The new hyped up position is context engineer. So as a context engineer, you want to craft how you make use of the AI's limited context window to give it the information in a structure that would enable it to succeed in its task. Right? And that's important. And that could even include, once LLM agent's context window is finished, right? Once it is filled, how do we compact that context so that we retain as much context as possible? If you realize in the early days, without automatic context compacting and all that, if you start writing a story with ChatGPT or some other agent, it will write the story, and after a few chapters, you'll start to forget what was written in the earlier chapters. You'll start hallucinating names and such, because certainly the story has just gotten too long for that certain for that certain chatbot to remember what happened. So one of the concepts that people are working with now is workflows. It's trivially easy, of course, to start a workflow in Claude or OpenAI ChatGPT. You can tell it, I want you to write a review of a certain paper, when you don't want to read it yourself. And I would like, 3 reviewers to read it, write a review, and I would like area chair to kind of synthesize, and I would like program chair to kind of approve that reading, or you might even ask it to stand out to do literature reviews. So the standard workflow, of course, is one that always follows the same sequence. You will see that a lot in companies or in government agencies, right? Where you have a fixed workflow, like applying for HDB flat, or doing a lot of approving a loan, applying for a trademark. These are basically fixed workflows that run from start to finish and give you a certain result. And there are also adaptive workflows where you might adjust which agents get the next task based on the output of the previous task. Okay, so an AI agent then is not just a model, right? It's not just the LLM model. You have the model developed, but it's just the language producing part of the agent. It can choose or propose next actions. It can plan ahead. But one of the things you can do is set a goal or a task for the agent. There is a planning mode and a goal mode in Codex, which is ChatGPT's coding harness. You tell ChatGPT that, okay, this is the task, and I would like you to plan, make a plan for finishing that task, and then after finishing the plan, I want you to pursue a goal. And the goal or task is essential to an AI agent, right? Because it is what it exists to do. The working record, in terms of context and in terms of memories, which keep relevant information from earlier steps in the workflow, so it doesn't forget important things, rules and limits, permissions, budgets, top conditions, human approval. You would have heard the news that Meta just spent $200 million on AI in a single month. Yes. So so their software engineers were not doing any real hand coding anymore. So they were just hand waving things, right? Trying to one-shot things. Hey Claude, I this thing I want to fix. Go through the entire millions of lines of code and help me refactor this thing. And Claude will very happily, send hundreds or thousands of sub-agents to help you look at this. And it will burn up a lot of money. A single request so you can just say, I want you to make a plan to do XXX. And once it finishes, right, it might take half an hour. And the plan could cost you like $2,000 or $3,000. So naturally, one of the problems with that is that AI is supposed to reduce costs. But if it is used improperly, and especially if you are built on a per token basis, and modern models can be very expensive. 1 million tokens is $50 for Claude Fable 5. So that is a single request can burn hundreds of millions of tokens if you don't scope it correctly. So that is a very expensive thing. So it's important to have rules, to have limits. You have agents in the past. Claude used to have a habit of deleting stuff from your home directory. It might say, okay, let me look into that. And it doesn't, it doesn't expose that it's going to do a certain thing, but then it goes straight and deletes a very important folder or database or such. And when confronted, the code, the Claude just says, oh, I'm sorry, I didn't mean to do that. And that's just too bad. And, yes, of course, tools are important. So you have a language model with tools and a goal and context working towards the goal within certain boundaries that are set by humans. And that's the ideal AI agent. Okay. So for instance, you might want to ask the AI to rebook a trip, right? So it will first, if you give it the prompt, it will understand the request, right? And so that uses their language and capabilities. It will then determine what queries it wants to send to the flight search engine. It goes in API, search for live options, flights, fees, availability. It will compare the constraints, ask for your approval. It will then book the flight and notify you that this is done. So this is an example of what a flight ticket booking workflow might look like. So you can give it different authority, right? So for instance, in many coding harnesses, you have different modes, right? You have ask for permissions, which means that whenever it tries to do something, it will ask for permission before touching a file system. There's a planning mode where it won't even try to touch anything. It will simply plan and tell you what the plan is. And then there is the automatic mode where it will send its actions on your file system to a different filter agent who will verify whether it's safe before allowing it to execute. Or you can entirely bypass permissions where you simply bypass all permissions and let it do whatever it likes. Of course, at your own risk, because it can definitely delete your home directory without much recourse. So So you can ask it for just advice. You can ask it to do some research on the internet, give it internet access, do some research. Or in this ticket booking scenario, you can give it your credit card details, where it will help you book automatically once you have agreed with it on what the best choice is. And that's something quite controversial. I think, was it ChatGPT or Claude that recently had an integration with MasterCard. So basically, if you have a MasterCard credit card, you can give Claude your credit card details, and it will help you buy stuff on the internet. Of course, if it hallucinates, then there might be very bad consequences. For instance, you might get 1,000 rolls of toilet paper delivered to your house. Yeah, so you can decide. Well, yeah, so as we've been saying so far, agent research studies the whole system, right? Not just the language model and the core which produces language, but when you look at the model, we look at instructions, we look at information, we look at tools, we look at coordination, we look at decision rules, and we look at the environment to see all things. Right. Okay, so now what do we actually research? Right? We want to look at whether an agent can complete a task. For instance, if you give a team of agents a workflow and ask it to perform, say, a loan approval task, we want to know at what rate we can actually complete the task. And task completion does not mean task success, right? It could complete and give you absolute rubbish as answer, but it could be complete. Sometimes it can't even complete because you want to look at reliability, and that's your completion rate. The success rate also is important. Whether it can satisfy the constraints is also important. Efficiency, we want to know how many tokens or how much money was spent on these tokens before we were able to finish the task. We have ticket flow, where we want to know whether an AI agent stays within the rules, right? We don't want to have so AI agents can do very ghastly things when it is given free rein. So for instance, it can when you ask an AI agent to do something and it has no authority, no permissions, smart AI agents can now actually try to buy the permissions on your computer. So it may look for loopholes which will enable it to do something it's not permitted to do if it thinks it's relevant to completing a task. For instance, if you have the API that you want to crawl, that you want to query, and you don't give the agent a key, the agent might actually go through an entire hard disk trying to look for API keys. And that's credential scraping, right, in your disk, and that's something you absolutely don't want to do, because that's basically what an attacker wants to do, and not really what the 9 agent should be doing. And recovery. So what happens after an error? Right, you want to know what the agents do. For instance, when it's blocked from taking a certain action, perhaps the agent tries to do something naughty, gets caught by the agent trying to verify the safety of its actions, and perhaps that agent provides the main agent some sort of guidance in terms of what it should or should not do. For instance, if Claude is caught by its own supervisor agent, it's normally some haiku or sonnet agent, but if it's caught scraping for credentials in a hard case, the safety agent will stop it and tell it, this is wrong. You should not scrape for credentials on the user's hard disk unless they explicitly tell you to, and do not try to bypass the spirit of this denial. And try to continue the task as you're instructed, right? But if you can't complete the task, tell the user so, and ask the user for permission for whatever it's doing. Alright, so nowadays, agent research spends many kinds of work, right? We have web and computer use. So basically, agents trying to use computers, smartphones in a way that a human might use it. And that web and computer use is basically the main product of manners, which was the subject of a huge hoo-ha in China at that time. Trying to buy it and trying to get it to get there to give this back to founders. We can do software engineering, which is what I use it for a lot. They can perform research and analysis. They can send teams of agents at a task. I talked about this just now. It can divide work. It can say we have a plan for this agent to do this part of the work, this agent to do another part of the work. For instance, when you're doing a web search, right? You might want to divide the keywords, you want to divide the subtopics among agents. Right? One of the reasons why we do this is because every agent has a limited context window, and if you try to get all the information into a single context window, it fills up. It doesn't, and the intelligence just degrades. And then, not to mention the huge amount of time we need. So, instead of getting one agent to do everything, it splits it into multiple agents to divide and conquer, where each agent does a certain amount of work that can fit into its context window comfortably. Robotics, right? Now we are looking at controlling robots using language models as well, or it doesn't have to be language models controlling agents, but it could be a language model. So that's a major area of research, especially in the warehouses. And now you can see in China and the US, they have the bipedal robots that are basically humanoid robots that are trying to do stuff like sorting packages in the warehouse and stuff. That's very interesting. Business operations, people are trying to automate things by speeding up approvals and such, for instance, and not just business operations. It can be also field operations, where you have electric utilities, for instance, inspecting power lines using drones instead of humans. And a lot of this is also agentic, like agent control, control. Okay, so when you test an agent, you might test an agent in a test environment on your PC, so everything is simulated. You might also test your agent in physical environments where you have something actually moving around or interacting with physical objects. So you observe the complete attempt, right? So you would try to get the agent to do a certain task, certain instance of a task, and it would start the task, right, have a certain boundary set for it, right? Perform certain actions. It might be interrupted, it might retry, and so on and so on. And there will be end status where it either succeeds, fails, or has some other type of error. Okay, so but basically, one of the major issues with agent research is that these rollouts are not published. So you might have someone who claims, okay, we have agent X that does task Y with a 99% success rate. But you know, if they don't publish the records of this, it's very hard to audit their claims or to say exactly what happened, because as I said, you know, these especially with agents based on language models, these things are not deterministic, and they could definitely give you different results different times. And you know, if you do not have an entire record of everything an agent did in a certain rollout, you're not going to be capable of auditing the results published. Yeah. So some typical workflow for agent researchers is that you want to choose. You have a certain environment, and you have a set of tasks. For instance, you have loan approval tasks. You have airline ticket booking tasks, and so on. And you get the agents to do what it did, all right? And then you observe what happens, and you apply a certain criteria to judge these agents' outputs, and you report the results. All right, so the outcome text itself can be very different, even when what has happened. The outcome text could be the same even when the actions taken are very different, right? So for instance, the booking might have been successful, right? And the agent says, yes, your trip has been rebooked. But for instance, and for most intents and purposes, the workflow is complete. So the completion is, for this, you have one instance of complete workflow. But for instance, the second instance in red might have ignored a cheaper option. It might have been over budget. It might have neglected to ask the user for approval before confirming it with the app. It might have failed to verify a booking reference once the booking has been done. So you know the user might be stuck with a reservation instead of a confirmation, and so on. So yeah, so both of this is technically successful in that a ticket has been booked. But you know, how do we define success? Is it something that is basically do we define success as a ticket has been booked, or do we define success as a ticket has been booked with all constraints taken into consideration? And that's something that different researchers might publish differently. So you might have researcher A who says, okay, both of these are successful. You might have researcher B who says that, look, only the first instance is successful. And they might report very different results, even for the same workflows, for the exact same workflows and action statement. And you might then be misled into thinking that, oh, researcher A's agent is much smarter because of the higher completion rate or success rate. But that goes further. Okay. So you also have the problem where sometimes agent rollouts, where rollout actions from start to finish, that are simply get interrupted. Right? They get interrupted because of perhaps network failures, because of different things that happen in the middle where it stopped and it did not proceed to completion. So are you going to look at the percentage of tasks that were complete and successful and neglect all the tasks which were interrupted in the middle? Or are you going to count the error out tasks as failures? Right? Does this sort of thing, reporting rules, it will change the numbers that are presented to the public in your publication. And if you have some researchers including interrupted tasks in the calculation of success rate, and other researchers that don't, then you are in some sort of trouble. Because then you are not comparing apples and oranges when you compare the results from different works. So the same task, if you apply different criteria, it might go to different scores. So let's say that okay, the agent attempts a booking of the flight, and the flight was changed. It was within budget, but it did ask for approval for booking at the airline. So rule A might ask, is the task complete? Yes. It was complete, it was within budget, but followed. No, because the user was not asked for confirmation. The third rule might give the agent partial credit for its intent. So So how do we ensure that agent research is reproducible? Well, firstly, we kind of want to know the recipe, right? What did we put into the agent? The task or the goal? The system sets up the tools, the permissions, the versions of software, and the boundaries given to the agents. That's the recipe for an agent that is performing a workflow. So if you do not know what a researcher did when putting the system together to run his workflows, then naturally you cannot reproduce it. Number two, you want a kind of a flight recorder. When a plane crashes, there's a black box that you can dig into and see what happens in the cockpit. So for agent research, if you want your work to be verifiable and auditable, you want to include some sort of record of all the actions your agent took during a certain attempt. It's results and its errors. Okay, so you want to have an inventory of every single attempt, even if it was leaked, it was missing, it was errored out, or it was given to some other agent. Right? And you need to have a marking scheme such that every agent can be judged on the same criteria. Right? And only when all these four are present, can you actually trust a number that has been presented in a certain paper. Because you'll be able to run it yourself and score it yourself using the same criteria. Okay, so that's pretty much it. Sorry for boring everyone.
Apply what kind of message to be made?
It's after midnight, so otherwise I won't be here.
You check the date, correct? Some people,
Yeah.
some
Yeah.
people go until midnight.
Yeah. Supposed to today midnight.
Yeah, correct.
It's
Tomorrow
not
midnight.
midnight. That means it's 11.
I got my
Tomorrow morning.
So it's 11
11
July.
July.
Okay, 11 July.
Calling at 0055.
Yeah, some people miss 11 July.
Maybe the day is tomorrow.
Yeah, 0055.
It's tomorrow already.
So the day is 11.
Yeah, some people miss the date. They thought 11, then 11 midnight they go on sale. Miss by 1 day.
Kind of an airline. Some airline really. Don't like one airline. 3 o'clock in the midnight. They close at 11:30. So you must come like 11:30. No.
Yeah, the airline, the
Come
ground
to the counter 11:30.
working hour.
But flight is 3 o'clock.
It's 4 hours almost.
Yeah.
Usually it's about 3 hours or 2 hours. Okay.
2 hours really normally, but the counter closed. You say
You're going home.
going home already.
And the staff going home.
11:30, you say I'm gone already. So you must come before that.
Checking before that.
Yeah. So sometimes it's what I mean. That's why now some of the counter is auto one, auto is okay. Self
So
serve.
we might have
Go to the machine and check it
Yeah.
out.
we might have this.
If the weather is
So let's have a look at how agents can be
No, they still the same.
deployed from top
I was in Japan, and I did do your own big thing, and
Decide
your
which one to
the
choose.
whole
So Haiku is the cheapest one, and Fable is the most expensive.
Correct, like when you pay.
Yeah, yeah, you're going.
No,
Which one is better?
half an hour
Just choose.
for the
So I
luggage.
just choose like
Pass
Oppo.
through
The
the
Opus is
pass through the screening.
yeah, it's
You
the
got follow
least,
us.
it's not the biggest
For
one.
you know,
Yeah.
So we always choose the higher one like
counter actually.
So the higher one is the higher one can be used as an orchestrator. So let's say you have a lot of agents that you are managing, and you so let's say you have a huge task that you're performing, and it's a very complicated task, right? You need some coordination between the sub agents. So perhaps you want a bigger model, a smarter model to be your manager, And this manager will take a look at the whole problem, try to get a global view, all right, and then it will write prompts for smaller sub-agents. And those smaller sub-agents will tackle their portion of the problem and report back to the manager. So what might, what some people do is that they use Opus to be this orchestrator. And Opus will say, okay, and you tell them to spin up a few sonnet agents to perform literature review on ad hoc. For instance, okay, so ad hoc keyword research is definitely a very large research area. Alright, so if you want to do a literature review on that, a single agent is not going to be able to do that. So what it does, essentially, so let's say, you want to do this, right? So you can say, I want this orchestrator to spin up a few, you want to use ultra code to see how it works. Ideal form.
Okay, so total is how much total?
Sorry?
What's the total quota?
I have, I think, I have tens of millions at least.
How you get it? Or school offer free?
Okay, so basically I have an API key for ChatGPT, but not for Claude. So this one I pay for it myself.
This one's clock.
Sorry, this is Claude. It's
So you pay how much a month?
200 USD.
What is it? My daughter 1 month use up 1,000.
Whoa.
Company pay.
The most I used up is 20K.
How you pay or 200? How you pay 20K?
So we have research grants to do that.
So some of the staff use up 10,000 a month.
Yeah.
So
So,
she only use 1,000.
so look at this. You when you do this, right? It starts a workflow.
When AI staff can eat up 250 million.
Yes, you can. Yeah.
But they done
Hundreds of millions of tokens, of dollars or worth of tokens.
they done the whole project inside, of course. Like you optimize, you only ask them to do certain thing, then there's
So this is the orchestrator starting. So I took Opus to orchestrate a workflow. Orchestrate this is a multi-agent workflow. Parallel sonnet agents, each surveying a distinct sub-area of ad hoc keyword and the several verification paths of their citations. So now it asks me for permission, right? So it has boundaries. It allow it to do so. And now you can see that it has set up some survey agents. It's always like this. So the agents are expanded. They are already using 183,000 tokens. And
$200 and something like that.
so I pay at least 100 million a month if you use it up. If you use everything.
But they quota like 5 hours and free.
5 hours and weekly, yeah.
My son asked one next question. use up 5 hours.
都是选一个
One question administration, one use up 5 hours.
Is he on the $200 plan?
$100. My daughter asked, hey, who use this now?
Does he use talk?
Drop.
He thought widgets are quite strict.
I use so many hours also being one question.
No, but if he's talking about advanced math, then
Don't know what
it will be, yeah, so these agents will, so basically what happens when you ask them very complicated questions is it spits out a lot of agents and it gets them to reason in a loop until it finds the answer. So
the AI can do all this, they don't need next professor.
no, so we did have the AI solving a lot of adult problems, right? So that's
Not research better problem.
no, but those were non-trivial questions which a lot of mathematicians spent multiple years on and couldn't find the answer to, and AI found it.
I read somewhere it says
90 minutes.
like they found 30.
Yes,
AI
yes.
found 30
Yeah.
problem. But the science mathematician look at it and say, all wrong one.
No.
Only one is correct. And then another fellow found that this correct one was because somebody has proven it.
Look, even Terence Tao was very impressed.
But they realized this one, it didn't solve on its own. He found somewhere a paper that related, but people didn't piece them together. So he used that research paper to piece together and he got answer.
Yeah. So
The solution already there, somebody found it many years ago.
But that kind of leverages the training data and the data processing capabilities of a computer, right? Because it might take a human very long time to piece those two things together.
Didn't read that piece of paper, forever don't know lah. You think again.
So you can see that the Opus agent has split the work into phases. So in phase 1, it is doing a survey, right? And then phase 2 is a verified pass. And phase 3, it will synthesize to see what insights it has from this literature review. So it's automatic, right? It has, once you tell it to do something, it will set up a plan. It will decide what sub-agents it needs to spin up. And it will ask them to execute the plan accordingly.
But you must know that you can ask, like sign up some sonnet agent, you must know. If you didn't have this phrase, then you don't know.
Yeah, you have to tell them, yeah, I want to use sonnet agents for this, I want to use haiku agents for this. Sometimes, a lot of cases, you just want to use haiku agents, but it's trivial tasks, right?
I read that I just use first. I don't know how to use each agent. I don't say all the same.
You might want to use 5.6 Sol. So it's actually very good. ChatGPT, it's cheaper than Cloud.
Say all agents are like human beings. Just like some are clever. Like you don't just use whatever one.
So if you want to waste how much? So I'm going to burn my entire. I'm not recording this, right? Right now it's recording.
It's recording YouTube live.
But why? So let's say I want to waste my tokens. I'm going to ask it to waste because I get 55 million tokens every day for free. It doesn't even count into the billing. So I can sorry. So there is a base amount of tokens that will give you
Or when you pay
every day.
the
Yeah.
subscription.
It's not from the subscription, it's from the API. Okay, so we have 48.9 million tokens.
How much is API?
So so it will so Claude is calling the OpenAI API now, and it will just use up 48.9 million
Maybe you
tokens.
spend the server.
Yeah, I'll spend the server.
Then after
I think 48.9 million tokens is worth like 200 USD.
then the server sold out already.
No, it's very concurrent. So there's a very high concurrency that they provide to.
After do some useful thing, write a program to do. So maybe you can create multiple programs.
So
But how you get the API?
you have to go to platform.openai.com.
Then means what API is?
API allows you to use it for agentic tasks. So when you're dealing with agents, you need to use API at times instead.
How to use the API? API normally I understand is call function program interface.
Yes. So basically, you want to use it in a headless way, right? Because when you use the Claude code, right, you're using it in an interactive way. You're interacting with with Claude, right? You can also use Claude or you can in this case, OpenAI agents in a headless way. So it does not have an interface. It's basically just a programmatic way of calling the agents. For instance, you have a program that has a fixed prompts that you use to call these agents and they give you a reply. So something of that as scripting. You can run a script that automatically calls the agents. Okay, so it refused to burn off aimlessly. It's insisting on using it on a productive experiment. So now it's setting up an experiment. You see what I'm trying to do. It refused to waste the tokens. Okay, so let me share with you the limits. Okay? So when you have an API account, you have very high limits. You can
API means because the write program API is call, you just go HTTP whatever the function.
Yeah.
Passing parameter by I don't see you pass parameter.
So it's happening behind the scenes, right? Okay, so basically you call we have API keys, right? We have API keys that and this key is used to call the OpenAI API. Right?
And you don't need to type.
Sorry? No, I don't, because Claude is doing it for me. This is programmatic calling of the API.
I don't know which key to use.
Because I've given the keys, I have put
But
the
the few keys, which one to use?
well, Claude has planning capabilities, right? It will plan. Okay, so let me look at the limits. Okay, so for instance, for API, you can put in 5,000 requests per minute. So you can throw 5,000 separate requests at it in parallel. So that's a very high concurrency. 5,000 requests a minute. Can you type 5,000 requests to OpenAI or the web portal? No, probably not. But for this, you can throw 5,000 requests at it in a single minute.
But when you type one question, you write a function to do this, then That one is not one request, it's maybe another. You just ask him to write a program.
It entirely depends on what sort of agent you're using. Right? If you're using a basic haiku agent, if you're just sending, if you ask it a question, it will provide a response, and that's just one request. Right? But if you're using Opus and it decides to spin up some agents, then it's many requests because when you have let's say the Opus spins up 7 more agents to help it split out its work, then that's 7 more requests. So it really depends on how you're doing.
TPN is a focus.
Focus per minute.
Per minute.
Yeah. You can use a lot of form. Which is, so for instance, 4 million tokens is for, let's say GPT-4o is $32. So every minute I can spend $32 directly on just 4 minutes.
Then why do people pay money when they say, well, it's free, right?
Because for every account there's a limit on how much you get for free. No, but a limit is nothing. When you have an agentic workflow, this is a very trivial workflow can use 800,000 agents already, right? Just now the workflow I started as a demo, it used 800,000 tokens. Yeah, so a million is nothing, especially for large tasks.
It's a minute, you talk about 1 minute, 1 minute, you get a 4 million.
Oh, but think of it, you can send 5,000 requests that minute.
But you don't have 5,000 jobs to do one.
Why not? So you have a huge code base. You say you want to refactor this code base. Then it sends sub-agents to examine every single class in the code base. Then it burns up very easily.
I also have to use something.
Yeah.
Mine is a simple, straightforward.
Some people are doing very complicated tasks. For instance, if you are, in fact, it's not possible to write code an entire operating system using Claude. Someone just spent a ton of money to write code their own operating system. So basically, a coding based on vibes.
What is vibe?
Vibes are like the vibes in this room.
VIBE.
VIBES.
What is that?
This is vibes. Like you go to. It's just a feeling you get in a certain place. Vibes.
I don't know.
Not like you might go to a dinner party and say to your friend, hey, vibes are very good here. It's just feels the ambiance, the atmosphere is good. So basically, vibes is basically you are thinking of something and you get the agent to code something based on your feelings instead of.
And if you can get like 4 million tokens per minute, now why do people pay subscription?
4 million, no. 4 million tokens per minute is not free, you have to pay for it.
Oh, you say all the API are free.
No, it's not free. It's free to a certain limit. It's free to a certain limit.
Then you pay.
No, but that free amount is going to be used up in 2 minutes.
Yeah, then next minute you still can get.
Yes,
Then
you pay for it, you have to pay for it.
Oh, must pay again.
Yeah.
Not every minute you can get 4,000.
Okay, so every day there's an amount that you can get for free. After you use up that amount, you have to pay for every token. This is just a rate limit to make sure you don't DDoS them.
So you have 4 million tokens per minute, then you just use then next minute you can use another 4 million, this minute another 4 million.
Yeah, that's the limit at which you can pay for the tokens.
But
Every
you pay
4
one
million.
time, you pay one time, you get 4 million per minute.
No. No. The 4 million is a limit at which you can send requests to OpenAI. You can use up 4 million tokens a minute.
Oh, okay.
But at the end of the month, they will bill you for however many tokens you use.
Oh, not
Yes.
to pay a subscription.
No.
Yeah.
If it was like that-
how to charge token, how many token? 4 million token is how much?
Based on usage.
25.
Okay, let me show you.
That's like electricity consumption.
No, it's not.
This one is like the transport lah, take aeroplane, take bus or take
Yeah, so you look at the pricing. So,
Cannot
for
spend so
instance,
small.
for some of the models, 1 million. So this is price per million tokens. So a million tokens can be $30. It can even be $180 based on the size of your model.
All count like token lah.
Yeah, yeah. So if you use 4 million of GPT 5.5 Pro per minute, and see that every minute you're spending $700.
Oh.
Yeah, so no, it's not free. Yeah, you have to pay for the tokens.
I thought pay for the speed.
No, it's not. You have to pay for the tokens. So however many you use, your employer or you yourself, if you are rich enough, will have to pay for the tokens. So you cannot anyhow use.
They say the API key is free.
It's free to a certain extent. For instance, they give you 10 million mini tokens every day. So for instance, GPT-5 mini, they give you 10 million a day for free, which is around $20 worth. No, it depends on it. It depends on
It's $20.
it depends on the agreement that your organization has with OpenAI.
Or not public.
You have contracts.
Okay,
Okay, so which is why I asked you that you're not recording right.
Yeah, it is. It's a YouTube live. Or not like public. I have a account. I just log in to check.
So you need to. So these are. Okay. So basically it depends on how big your organization is.
No, I mean,